All right, you guys, let's go through a few of these things that you're gonna kind of have to know and remember now that you've had a chance to look at a few of the examples. All right, so we already talked about the carbon, right? If you have a whole bunch of carbon in the formula, you're gonna join them all in the middle. You'll still count up all your valence electrons and put those in. So let's go ahead and finish this example together. So we've got 5 carbon. Each carbon have how many valence electrons? They each have 4. Okay, and there's 5 of them. So instead of writing 5 separate ones, I'm just going to put 5 here. 5 times 4 is going to give me 20. Okay, so I'm going to have 20 valence electrons just for the carbon. And then I have 12 hydrogens. They're each going to have 1. So that gives me 12 more. So that means when I'm done with this, I need 32 electrons in my structure. All right. So if we just draw all the hydrogens in, since I already did all the bonds. Okay, then we just have to make sure that everything is full. So we've got 8 valence electrons there. We've got 8 here, 8 here, here, and here. Okay, so those are all full. You can see this gets a little crazy when they're big molecules. And then we've got 2 for every hydrogen. I'm not going to circle every hydrogen, but you can see that, okay, in this example. So we have full shells for everything. Now we just have to double check. Carbon has its 4 bonds. Hydrogen each has its 1 bond. So that matches our Honk rule. Then we need 32. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So all 3 things fit, okay? So remember, you're counting your valence electrons. You're using the Honk rule to check that carbon has 4 bonds, hydrogen has 1. We don't have any oxygen and nitrogen this time, so we don't have to worry about that. And then we check that everything has a full shell. So those are the 3 steps. All right, so things to remember. If we have free electrons, you have to make sure you're drawing those in. When we did our carbons and our hydrogens, there were no free electrons. They were just all bonds. But when we get into some of these other structures, oxygen only makes 2 bonds usually. So if it only makes 2 bonds, that's only 4 electrons. So you have to make sure that you draw your free electrons in pairs. Remember, they always have to be paired up. When you do that, electrons want to repel each other. They want to push away from each other. So if you have a whole bunch of free electrons, they're going to push away from each other and your bonds are going to be angled. We did this with water. Last chapter, we showed how this was an incorrect structure for water, that when you have free electrons, they go on the top of your oxygen. These want to push away from each other because they're all negative. Your bonds are also negative, so they want to push away. And so you have these bonds that are angled downward. You have to draw it that way or it's incorrect. So free electrons, you put at the top and you push your bonds downward so they're angled away because of that repulsion. Okay? If you don't do that, those are incorrect. So make sure where you have free electrons, you're doing that. So that's an example with water. Here's another example with ammonia. Okay? That would be incorrect if you drew it straight across because the free electrons here are going to repel and push away from each other and make those bonds angle downward. Okay, so make sure when you have those free electrons, you're looking at that. Okay, then the example I had up here first, you've got a couple where you've got a carbon and an OH, okay, or something and an OH bonded together. For that oxygen, the free electrons again are going to be at the top and that hydrogen has to angle downward. All right, so make sure you're doing those things. I think those are all the examples I had up here to go through. All right, so let's go through this one together. I'm going to show you another step that you can do if you want to be able to figure out how many bonds you have without having to guess. So we already talked about how we figure out our number of valence electrons, right? What group we're in. Carbon has 4. Oxygen is in group 16, so each oxygen has 6. So if we add those together, we would need 16 valence electrons. Okay, so that's the one that we have to double check in the end. If we want to figure out how many bonds we have easily, okay, we then look at all of our atoms and we write down the number of electrons that they need for a full shell. So basically every atom needs how many electrons for a full shell? except for hydrogen. Everything else needs how many? 8, okay? So it's gonna either be 8, or if you have a hydrogen, it's gonna be 2. So we've got 3 atoms here. They all want 8 to have a full shell. So that would give me 24 valence electrons. If we take these two numbers and subtract them, that tells us how many electrons should be in bonds. So we just take 24 minus 16, and we have 8 bonding electrons. Well, each bond, we said, has 2 electrons, right? So if we have 8 electrons in our bonds, how many bonds are we going to have? 4. So we know when we draw this structure, we need 4 bonds. Okay. So that's an easy way to figure out how many bonds you need before you start drawing, so you don't have to erase electrons and move them around. Okay. I believe all that math is on the sheet that's over there. Okay, so that's you don't have to do this. You can just take your total number of electrons and move them around until you get it to work. This is a shortcut, though, that makes your life a lot easier, so you don't have to erase and move all the time. So we've got carbon and 2 oxygen. Carbon goes in the middle. We've got an oxygen on each side. But we need 4 bonds. So I can't just write it like this. What do I have to do? We need 4 bonds. Remember, we did this one a while back. Sure, we have to double bond it, okay? So remember that we can have double bonds, and sometimes we'll even have a triple bond. So we'll double bond that. That gives us 4 bonds, like the math told us we should have, okay? Now we need 16 electrons total, and we need to make sure everything has a full shell. So carbon has a full shell here because there's 2, 4, 6, 8. My oxygen, though, only has 4. Right, oxygen has 2 bonds like it's supposed to, but there's only 4 electrons here, so we have to add those extra 4, and we have to do the same thing then on the other side. So everything has a full shell, everything has the correct number of bonds. Now we need to double check, is there 16? 2, 4, 6, 8, 10, 12, 14, 16. So that's a completed structure. So some of these more difficult structures that you're going to get into on that other practice sheet, you may want to do this extra math to figure out how many bonds you need to do. All right, to make it a little bit easier for you. If you don't understand it, ask and I'll come around and we'll go through a couple together individually. And if you hate it, don't use it, okay? Just go with your total number of valence electrons and your ring. So go ahead and try a few more examples and see how you like that.